The image you're seeing gives you an idea of the smallest quantum reality. The flickering colors represent the constant creation and destruction of matter and antimatter. Electrons and antimatter electrons, quarks and antimatter quarks, they are created from nothing and disappear back into nothingness. We can see that when we look at what is going on at the smallest and most quantum of scales, that empty space is actually extremely busy. Scientists have a name for these effervescent subatomic objects. They are called virtual particles. There are lots of other ways to visualize this, but one way is to think of the foam on a particularly fizzy root beer. If you look closely, you can see bubbles appearing and disappearing in an ever-changing way. For this reason, some scientists call these virtual particles quantum foam. Yeah, I know. This just sounds entirely impossible. So how do we know it's true? There are lots of reasons, but we can talk about two that are really totally cool. The first one is what we call the Casimir effect, first predicted by Hendrik Casimir. This effect is pretty easy to understand. The way it works is the following. Start by assuming that virtual particles exist everywhere in space. Now, take two metal plates and put them near one another. Let's think about what's going on. You've heard that in quantum mechanics that particles have both particle and wave properties, and this is true of virtual particles as well. These virtual particles have both long wavelengths and short ones, and everything in between. Furthermore, they occur everywhere. However, the plates introduce a new factor to the situation. Outside the plates, both long and short wavelength particles can exist. However, between the plates, long wavelength particles can't fit. Thus, there are more virtual particles outside the plates, and the imbalance causes the plates to move together. So what do we see? Well, when we do the experiment, we see exactly what Casimir predicted. This is considered very strong evidence for the existence of virtual particles. There is another measurement that supports the virtual particle idea. This has to do with the strength of the magnet formed by individual electrons. Electrons have electric charge, and they also act as if they spin. Just as in the classical world, a rotating charged object becomes a magnet. And because we know the electron's charge and spin, we can predict the strength of the magnet each electron should be. When the prediction and measured strength of the magnet formed by an electron were compared, there was a tiny discrepancy. They disagreed by 0.1%, 1 part in 1,000. A small effect to be sure, but a disagreement nonetheless. However, when the simple calculation was replaced by one using quantum electrodynamics and virtual particles, the agreement between data and theory was restored, and the restoration was better than anyone dreamed. The two numbers now agreed to 12 digits. This is the most accurate measurement mankind has ever made. This incredible level of agreement is believed to be definitive evidence of the existence of the quantum foam.